So here we go. Let's start to stuff that right here. We've got to change this to the y equals mx plus b form. But circle your keyword. The whole point of these first examples is this. It's got to be parallel. So the parallel lines have to have the same slope. So what I highly suggest you do first is come to your equation right here and pull the slope out of it. You just got to remember where the slope is. It's always in front of the x. That's the only thing we're going to use from that. So we're just going to use this. We're going to use slope equals 4. That's it. The rest we don't need. Okay, then you come back to your point. Points are always in the form x, y, right? So we're going to use this for our x and this for our y. Negative 2 is on the x-axis, 2 is on the y-axis. And then we stick it in that y equals mx plus b. So I suggest just write y equals mx plus b, and we'll replace what we know. Let me know if I'm going too fast. Okay, so instead of putting the y, put a 2. Instead of putting the m, what are we going to put in? 4. Perfect. And then instead of the x, perfect. And then we always have a conversation, what are these two doing to each other? They're timing, so I have my students write like this. And then this is the whole point, we don't know the b, so we just write plus b. We've got to find it. Good so far? So just replace the variables. So we'll have our 2 equals 4 times negative 2, negative 8. Add it to b. Now yes, you're adults in here, so you can do it in your head. Negative 8 plus what would be 2? Or you can do the inverse operations, that's what I teach my students to do. So right here, this is a negative 8, so we practice adding 8 to both sides. Inverse operation to isolate the variable. So final answer for B, 10. That's all right. We'll do more examples if you're like, I'm kind of with it, but not quite. Okay, one more step and then you're done. You just have to put it all back together. So we've got to go back to this form, y equals mx plus b. The only thing you do is you replace the m and you replace the b. Keep the y and the x. So final answer would be y equals, don't put m, what did we use for m? Put the 4, keep the x, and now we found our b. Was it a positive or a negative? So you just write plus 10, it's like a positive 10. This is your final answer. What you have just done is you have found parallel lines to this equation. If you graph those two equations, they'd be parallel. Big guy, right? Should we do another one? Feel free if you're like, I got this. You can keep moving, and then just check on the board. Number 5. Don't be nervous about that fraction in there. You know? It's a little bit bigger. Okay. So same exact steps. So let's use m 1/3. That's the only thing we use from that equation. This 6 will be an x, and this 4 will be a y. Yeah, question.
Well, I'm just wondering that, like, where would you come up with that, or what? Why are we trying to find these parallel lines? Or where would be?
This is pure graphing for the geometry, so we'll go back and we'll graph them. Actually, I'm not sure if that comes up in the lesson, but it's the algebra behind it to show. We talked about parallel lines in geometry, and this is why they're parallel, because their slopes in the equation have the same exact number. Does that answer your question?
But can I pick another point and it would still work? Like,
Yes.
I said like 5 and 2.
And then you would have to have this given to you, at least, because you would need to know what you're trying to make it parallel to. That's a great question.
So I can pick whatever point I want.
The only thing is it might be a little bit messy, like choosing stuff that's pretty nice with each other. Yeah, great point. Thanks. Okay. All right, let's stick this into the y equals mx plus b slope intercept form. So this would be 4 m 1/3 x6. Oh, I'm so sorry. My b's and 6's are very, very similar. Okay, if you're not quite sure, you can use a calculator. Do not mind. But 1/3 times 6 comes out super nice. It's just going to be 6 divided by 3. Yeah, so just be 2. Okay, and then right here, hopefully you can just be like, well, plus 2 is 4, and just be b is 2. How many of you got that? Did you get that? Did you beat me to it? Okay, perfect. So stick it back in the formula. Keep your y. Replace your m, it was 1/3. And I just talked myself through it. That's a positive 2, so that'd be plus 2. Okay. Can we set you loose on the bottom too? Go ahead and try. Try the next two. Try to give you plenty of room. I am visual. Yes, the algebra makes sense, but I, like Vanessa pointed out, I like to see what we're doing. So this first one, number 5, I'm just going to graph these real quick for you. Now, don't stress out, because this is not part of today's lesson. You don't have to show out. How did you graph that? I just want you to see it after I graph it. So y-intercept. So that's the first equation. Next one would be up 1. So right next to it. So that's what you did. I'm sorry, those aren't very straight lines. So you're just showing that they both have the same slope, but they're going to cross the y-axis at a different spot. And then if I was better at graphing it, it should go through the 0.64. Yes. Okay, give it about 30 more seconds and we'll go to the backside. Backside is perpendicular.
I know nobody's hoping. Well, I just didn't want to get dropped. Yeah, I got that. Oh, thanks. Did you have those with you?
Oh, where was it?
You did?
Oh, that's one.
Let me tell you, that's my only. Okay. Open. I just want to go try. No. Oh.
Bad boy up. Just circle your keyword. So backside is focused on perpendicular. We're still using y equals mx plus b. It's all about this one still, the m. So instead of pulling the exact same m, we've got to do something for it. So let's just make a quick example. What if it was y equals 2/5 x plus b? Oh, well, we would have a number there, not b. Okay, if it was parallel, we would just use 2/5. But it's got to be perpendicular. Now, do you guys know about positive slopes? I assume you do. So positive slope, we're going up the hill, right? But if we're going to make a perpendicular, don't you agree it would have to be a negative slope? It would have to be the opposite, so they cross. So first off, if it's positive, you got to make it negative. So it's the negative reciprocal, but then you've got to flip it. So you pull this, m for perpendicular slopes. Because this upside down t means perpendicular. Flip it upside down, so it would be 5 halves. But you can't forget to make it negative to make them cross. So you've got one positive slope, one negative slope. They cross each other. So again, it's the negative reciprocal. Flip the slope, make it negative, or if it was negative, make it positive. Let's do another. So what if it was?
Wait a minute, so you're, wait,
Go ahead.
so you're flipping it from 2/5 to 5 halves and putting a negative?
Mm-hmm. It started positive, you gotta make it negative. We'll do that. Let's do one more, just made up example. What if it was y equals negative 1/7 x plus 8? Okay. So flip it. So the m for a perpendicular, flipping it would be 7/1, right? And it was negative, so you want to keep it positive so they cross. Yeah, you could just use 7. Woo. Okay, let's do one together. Okay. So this first one, again, the only thing we need from this equation is the slope. But since it's a perpendicular slope, Flip it upside down. Make it negative, and I love that you guys are just being nice to yourselves. Might as well just use negative 2. And then it's the exact same steps for the front side. So use 4 as your x, 2 as your y, but this time you're going to use the perpendicular slope. So again, all about slope intercept. Replace your y, use the 2. Use the negative 2 this time for your m. And come back here, use 4 for your x, so it's making sure it's going through 4 2. Plus b. And you can think to yourself, or add the opposite. Add 8, then put it back into your slope intercept. I got 10 also. How many of you got 10? Can you get 10? Okay, sweet. No? Yes? So we got y. Keep your y. Okay, what was our slope? Negative 2 for the perpendicular slope. X, and we got a positive 10 for b. Final answer.
Y equals negative 2x plus 10.
Okay. Same thing as before. I'll do the second one on the board, but if you want to try it on your own, go for it. Flip this, take off the negative. X, Y. Alright, those of you jumping in, did you get negative 6 for me? Final answer? Okay.
Minus 6.
Oh,
We're
okay.
subtracting.
Okay. Thank you for checking. So final y equals, what was my slope? 3/2 x, and then I'm just going to put minus 6. Yeah.
Or the
top.
3 Got one on the top and one on the bottom.
Feel free to keep going. You got it. Keep going. Keep going.
2. So say wrong.
Okay, same thing. I'll record this part, so if you need extra help later, you're more than welcome to watch the video. So the very first type of angles you need to know about are called corresponding angles. So when I have my students, we usually are in groups of 4, but that's not fun for adults because it's the bar and you gotta climb over stuff. So in groups of 4, we talk about corresponding seats. So for example, right here we've got Amy in this spot, skip a spot, Summer in this, not Summer, Stephanie in this spot. They're in corresponding spots, they are congruent. So right here, this angle always is going to be congruent to this angle. They're in the same spot. I teach my kids there's 4 spots. 1, 2, 3, 4. This one, 1, 2, 3, 4. They're both in the top right corner. They're corresponding spots. They're congruent as long as those 2 lines are parallel. Oh, and then congruent, we worked on our vocab. That just means the same measurement. 25 and 25. 40 and 40. So there's one pair. Another pair. We've got alternate interior. I like these ones. And it hopefully will be easier for you than my students, but alternate interior, I feel like those 2 words alone describe it. They've got to alternate, but they have to be on the inside. So inside, talking about the parallel lines. Inside would be right here, the interior. So they have to be on, so this one is congruent to that one. Alternate interior is always congruent. Question, Sarah.
Okay, so what's this wavy line? That
Oh,
means
thank you. Yep. Good one. There's symbols for everything in geometry. I shouldn't say everything, most everything in geometry. Okay, so check, we've got corresponding are congruent, they're in the same spot. alternate interior, alternate sides on the inside, they're congruent. This one, consecutive interior, not congruent. This big word. Supplementary. How many of you have to teach your kids supplementary and complementary? Do you teach them the SC trick? Okay, SC trick. So you've got supplementary, complementary. So I make up a story, and they tell me since I couldn't remember the difference when I was in geometry, and then a cute boy turned around and said, "Why are you messing this up?" And he showed me a trick. So here's the trick. One of them equals 180, and the other one equals 90. So this pretend cute boy, they don't know it's pretend. He says you only get one straight line. Make a straight line. What number does that look like? So that's the 180. And then you get one straight line for the other one. Kind of looks like a 90. So 180 supplementary. And then 90 complementary. So these ones, consecutive interior, consecutive one right after the other. Interior on the inside. With these two, when they're on the inside but they're on the same side, you add them up and they equal 180 every time. It's the only pair of angles where they're not congruent. Quite nice that they always equal 180. Okay, last one that we're missing. Alternate exterior. So exterior we talked about, that's the outside. They've got to be on opposite sides. These ones, again, are last pair of congruent angles. They'll be equal to each other every single time. So we tried to simplify this, and I just really focus on, guys, just remember consecutive interior are supplementary. All the rest are congruent. And then we practice. So the next part is just a blank.
Can you say that again?
Consecutive interior are supplementary.
So show me on the.
Right here, so if I add this is angle 2, this is angle 4. Add those two together, 2 plus 4, angle 2 plus angle 4 equals 180 degrees. And then the other pairs are going to be congruent, so let's practice them. So the next part, just totally blank. Try it. I'm going to give you two angles and just tell me the relationship. So how about angle 1 and angle 5? Feel free to copy this down as you want to.
Corresponding.
Yes. And then corresponding angles are congruent. So they're in the same spot. They're both in the top left. Corresponding congruent. Perfect. Okay. So what about, how about angle 4 and angle 5? These two. Oh, perfect. And then what about them? What about alternate interior?
Congruent.
Perfect. So angle 5, angle 4. I'm just going to put that alternate interior. Okay, what about angle 8 and angle 1? I kind of give it away by my symbols. Perfect. And then what's their relationship? They're congruent. Does any of this sound familiar from geometry class way back when? No? Okay. We're going over it. Alright, alternate exterior. Okay, what about angle 3 and angle 5? Way to process elimination. Perfect. But however, are these ones congruent?
No.
And I hope that makes sense logically because as you look at the shape of those angles, they won't be the same. So consecutive interior, supplementary. Add them together, they equal 180. Okay, I'm going to stretch you a little bit. We've got one example of each. Will you go back and put in your own example of each? Just look at your picture. There's more than one of each type in the picture. Okay, I'm going to start you. Does anybody mind sharing their corresponding angles example? What did you put for corresponding angles? We have up here 1 and 5, but what's another pair of corresponding? 2 and 6? Totally would work. Thanks, Jess. Angle 2 would be congruent to angle 6. So there's another corresponding. Alright, alternate interior, guys, what would it have to be, the other pair? Perfect. 3 and 6 would be the other pair of alternate interior. Okay, same with alternate exterior, guys, what would the other pair have to be? And then, yep, same with consecutive interior. What's the other pair of consecutive interior? 4 and 6. But those ones aren't equal, they're supplementary. Add them together, they'll equal 180 every time, as long as the lines are parallel. So I guess another thing we can sum up from this, corresponding angles, there's 4 different types in there. Everything else, there's only 2 different examples. Okay, do you have any questions on this? Questions?
So would angle 7 and 8 just be supplementary? Is that,
Yes, good work.
so they don't have, do they have to be interior?
No,
Is that
it's
how
not.
they-
To be supplementary, they don't have to be interior. The vocab for that one, good job, Rosie. This is called a linear pair, because they form a line. 2 of them, they form a linear pair. You know what? Oh, I think I almost jumped again. Flip over to the back side. Oh yeah, we have that example. Let's do that part first. Okay, so this one, they give you a measurement, and everything else will fall into place. So I coach my kids, draw on the pictures. We do not care if you draw all of this, and it's yours. So all we know is the angle one is 118. Jump around. I don't care if you go in order, A, B, C, D. Anybody hand in the air? Well, if that's 118, this would have to be. Yeah, that's okay. Sarah said 3 would have to be 118. How come? Yeah, it wouldn't hurt to write that under angle 3. Just put corresponding angles as a reminder. So that one's 118. Okay, how many else got another one? Yes, angle 4 is 118, but do you know why? Perfect. So where's angle 4? Alternate exterior is angle 1. Okay, and then you can look at Lacey talked about. Or 3 and 2, something about those ones. 62 for angle 2. Alright. These ones, 62, because those two have to add up to equal 180. So what's that? 62 for this one, consecutive interior. Okay, and then if that one's 62, 5 would have to be. Yep, because they're alternate interior. Okay, guys, questions on this? I'm more than happy to help you with. Okay, the last thing, before the next example, technically you could have used something else on this picture. Are you ready? There's vertical angles. Vertical angles across from each other, 3 and 4 across from each other, they will always be congruent too. So I'm so glad you guys said alternate exterior, because I was thinking vertical angles, 3 and 4, 118, but we haven't got to that yet. So middle of the backside. Oh, maybe. Vertical angles, again, they're across from each other. So first pair, angle 1 would have to be congruent to angle 4, because they're vertical. Teach our kids they're looking at each other. Shout another one. What's another pair of vertical angles? Perfect. 2 and 3. What's another one? Perfect. And then the last one? Perfect. Those ones will also be congruent. So it's another set of angles that you are more than welcome to use whenever. Okay, let's review real quick. Guys, what does supplementary mean? 180, right? Makes the S, you can change it to an 8. Supplementary, so will you try that very last example? It says list several pairs of supplementary and vertical angles.
It's not a pair, it's 3. Right?
Right.
Yeah.
Guys, check out this. Would angle 2 and angle 6 be vertical angles? Be careful. They literally got to be staring each other in the face. Angle 2 and angle what? Perfect. Okay, so this one, yes, it says pairs. Yes, it says 2, but it's always how it's said in geometry. Can I get a volunteer? Do you mind giving me one combination that is supplementary? These 6, 1, 2. Perfect. 6 plus angle 1 plus angle 2. Think somewhere 180 degrees. So I have my kids highlight it. Here's the line. Well, it makes up the line. Put 6, 1, and 2 together. It's actually a really good segue into our next part. Yeah. Yeah, exactly. You could have switched it somewhere this way and done 1, 2, and 3 and had them in the back. Logan, Megan, Linda were talking about that one.
But then you can cut it do
2, 3, 4. Yes. Guys, good work. Okay, this is purely for your reference. Big concepts, the corresponding consecutive interior. Okay, next. Remember I told you you're going to cut up the paper that you just drew pictures on? Get ready for it. What you need to do is grab your ruler. Pencil or pen, doesn't matter. Scissors are ready. Okay, all you need to do, really hits home with works also. What you're going to do is first use your ruler, use your pen, pencil, make a triangle first. Doesn't matter how big, how little. Honestly, the bigger it is, the much easier it might be, but you can still do it. I'll do the same. Find the paper. Doesn't matter where, just know you're going to cut it out. So draw with your ruler, cut out with your scissors. Yeah.